Example 2, find the area of the region bounded by the graphs y equals e to the x, y equals x equals 0, and x equals 1. How do we start? We start by sketching a graph. So here, let's throw in some axes here. We need an exponential function. You know what? It's this thing that's right there. I'm just going to copy that. I'm going to copy the color too. It's going to be purple. So here's my exponential function. And then we also need a linear function, y equals x. What could be simpler? This thing here. And then we're going from 0 to 1 yet again. Let's pretend like 1 is way the heck over here, just so I have a kind of a large region to actually find the area and draw stuff with. Okay, so let's color it in. It's the most fun part of this whole thing, so don't avoid it. Okay, and then, hey, what do I do next? Let's at least draw in our representative rectangle here. Dot, dot, draw in our rectangle. Oh, it's perfect. All right, and then we have a width of delta x, and our height, we can see the top function here is e to the x, and our bottom function here is the green one, which is x minus x. All right. If I were going to do that whole process of turning this into a Riemann sum, it would be summation from I is equal to 1 to n of, and then our height function is going to be e to the x. It would be sub I with a little star on it, yes, minus x, again, with a sub I and a little star on it, however you pronounce that, multiplied it times our width. Take the limit as n approaches infinity. When we do, that turns this thing into a definite integral from 0 to 1, right? Because that's where we're going, from 0 to 1, from 0 to 0, brilliant. And then this will be e to the x minus x dx. So, at the very least, do a couple of these. Whenever you set these things up, whenever you're doing your own little practice problems, do a couple of these where you're drawing the little graphs, drawing the representative rectangle, and turning it into the limit of Riemann sum. Again, as an exercise to reinforce the definition of a definite integral. And from there on out, get in the habit of at least drawing in your little representative rectangle. It's going to be important later on, I promise. Okay. So just take my word for it. What's the antiderivative here? We have antiderivative of e to the x is e to the x minus an x squared over 2, and we're going to evaluate that from 0 to 1. So this time we do care about the 0 because we have an exponential function in here, so we do have to actually evaluate it. So we would have e to the 1 minus 1/2 minus the quantity e to the 0 minus 0 squared, so I don't have to put that part there. Okay. All right, so simplifying here, we have e minus 1/2 minus e to the 0 is just 1, which is essentially e minus 1 is 2/2 for a total of minus 3/2. Right, there we have the area bounded by the graph, this exponential graph, e to the x, and this line y equals x. Hey, as a matter of fact, I didn't even have to draw a thing because it's right here. It's been here all along.